Okay, so if you type cd then proc, then you can go to the folder where all the current process will be showing there. So if I write ls now, you can show all the process here. Now, if you want to see the details of a particular process, then I said you can you can write, you can go inside a particular, because each process has a folder here. So suppose if you want to go inside a process called 361, then you can write 361. Then now you are inside that process. If you want, if you write ls minus l, you can see all the files of that process here. There are many files associated with a particular process. You no need to understand all of them, but there are some file which is important. One of them is called maps. Maps will tell you all the details about the memory about it. So if I write maps now, sorry, cat should, I think this is maps is here. Huh. So this is I think system file. So it was asking for my permission. So whenever you'll open a file, you'll see this type of details. This is all the distribution of virtual memory. Which memory region is for which part is for code, which part is for heap, which part is for stack. All these details you will see. You will not find all the details for an user process. I think this is a system process. That's why it is showing all these details. Anyway, so this I think I have already explained in last class. So let me check how many processes are running from. Okay, so suppose this process 517. So yeah, if I want to see about 517, then same thing we can do. Now you can write here, then 517, and then you need to write maps. Then you can show this. So I hope you're understanding why previously I just used cat and then maps, and here why I am giving full path, because you need to give the full path based on where you are currently. You see the current position. You are at a home folder now. So from that, if you want to open a file which is not in that folder, right? Same, I have explained it for HTML also. If something you are trying to open which is not in that folder, then you need to give the relative path. So from where you are trying to open something sitting in a folder. From there, you need to first open proc folder. Inside proc folder, there is a folder for 517 process. You need to go to inside that folder, and inside that folder, there is a file called maps. You want to open that. That's why you need to give full path. And see here, this is the distribution of your virtual memory for this. So last class I have explained that this is for code mainly. It is there already. I have already discussed. So let us not spend time more on it. Heap is there, stack is there. I've explained. Now, if you want to know more about the virtual memory, there is one more command is there. I think ps minus p, and then what is 517 is the process ID. Okay, and then I want suppose PID, VSZ, and RSS and CMD. If I write this, okay, maybe I have done some mistake. PS minus P517 minus O, PID is fine, then VSZ is fine, then RSS. I don't know what is the mistake. RSS and CMD. Yeah, it is running now. So if you see here what it is saying, this is PID, this is the process ID. VSZ is the actual virtual memory size in KB, I think. This is in KB. So this is the virtual memory size in KB for this process. And this is the actual memory now it is currently holding from main memory. I hope you remember the example last class that your entire virtual memory may not store in main memory, right? Some of them will store in swap space of your secondary memory, and only a small part or important part will be there in main memory. So you can see how many at this moment currently there in main memory. 768 KB is currently in main memory. Remaining things are in Remaining things are swap. But there is a important concept that I have missed in last class. It doesn't mean that at this moment the 2680 KB is already reserved in swap. It's not like that. It will be given on demand. So now maybe this much is there. After some time, it may increase also based on that on demand. It will increase or decrease. Huh? Just go. 1 minute. Hello. না মনে হয় আমি বলতে খুলি নাই okay huh okay so virtual memory I have just explained to you now. Let me go to my previous file here, so I'll stop it here. You need to check more about this, that what is VSZ, what is RSS, that based on that you can see the memory size and all. There is one more thing that I need to explain, but before that, I'll show you a program here. Let me start with the program from this same folder. Okay. Where is this? Simple. Okay, let me run this simple command here. GCC sim. This is a program which will just run for infinite time, right? If you see the program here, this is not doing anything. There is an infinite while loop. What my intention here is, I just want to keep one process active. So this process is running now. And now if you see here, PS minus AF, then you will see the process here. The process ID is 6060607. This is the process ID. What is the parent of this process? What is the parent ID of this process? 315. So can you see which process is 315? It is showing here. It is not showing here because 315 is may not be a process that I have started. See the first column here. It is showing the user processes, the process which I have started. The maybe this process is not started by me. It's maybe started by kernel. So if you want to see more detail, write P minus EF, not AF, and then you press enter. Then see, you will see a long list of processes which are not directly created by Sirshandu. There are other users also, root users also created. So basically, these are all are from user domains only. They are not for kernel for process, but not from the this user. So this is the user called Shirshandu, but there is one more user here called root. So now you can see do some interesting tracing here. So where is that folder? Simple is here 607. So 607, the parent of 607 is 315. So now go to 315. See the 315, the parent of 315 is 314. Now if you want to go, if you check 314, then 314 is here, whose parent is 313. Now if you go 313, then parent is 2. If you go to 2, then parent is 1. Then this is the parent. Okay, so now you will understand that as I said in initial class, then whenever you are starting your computer, first the kernel will start, and then kernel will start one single process, and that single process will be responsible for creating all other process. And I'll show it in a different way also. I think ps3 minus p, that should be the command. Can you see the tree? If you see the tree, then you will understand. First process is called system D, sorry. So kernel will once your machine is started. I hope you know about the starting process, right? The moment you switch your power button, how computer starts, that I have already explained, right? So now first BIOS, from BIOS to Linux kernel. Once Linux kernel is loaded, then what will happen? Then first process that it will Linux kernel will start is called system D. System D will be process ID 1. And you can see all the process here are actually connected through system D. Where is our process? Can you find our process? Our process ID is 607. It is here. 607, right? Who is the parent of 607? 315. What is that? Bash. Bash means this terminal. The terminal from where we are running, not this one. This one. This bash, this is called bash. So maybe this is also same bash, I think. Yeah. But no, this is a separate bash. So this bash is this terminal will call a process. This process is called bash. And this is showing here. And it's called 315. Okay. After this, the next one, the bash is also a just 1 minute. Hello, আমি ক্লাসে আছি। হুম। So now the next one is relay, and then next one is session leader, and then init system D. So these three, init system D, session leader, and relay, these are not the actual process. You may not see them in your machine when you run it in actual Ubuntu, because I'm running it in WSL. That's why these three are coming. So after the parent of bash, that is relay, and then session leader, and then the next one init system D. These three are mainly connected with WSL. So if you are using it directly in a Linux environment, maybe you will see system D. After system D, you will see one more. I think one more process is there. I forgot it, and then directly you will see bash. You will not see this intermediate process. These intermediate processes are only coming here because of WSL. But I hope here, even these things are there. You can see the relationship here. There is a single process. And from that single process, all other processes are generating, right? So now you can see what is this 615. 615, what is written? PS tree. Can you guess what is this? Just now I have run PS tree, right? The moment I ran PS tree, it was also creating a process. And that process it was showing here. And that PS tree from where I have started this particular terminal, that is called bash 501. So that's why I said this bash and this bash are not same. You can see from here, they are different, right? So this command is very powerful command, ps tree minus p. Minus p is an option, ps3 is a command. You can use with combine with the other option also. One interesting point, one part that traditional way to understand a command is you just use man and then write ps3. Then he will show you all the document of ps3. That is the traditional approach, right? You will not follow this approach. You just spend some time on ChatGPT. So this is our time. We need to read the manual. Any command, it's a ls command or ps command, whatever it is, you just write man ps man ls, then it will give you entire manual of that here. And just next, you just press Q, you'll get back here again. You can do this, or you can spend some time on ChatGPT. Now I'll show you some document. Those I have generated from ChatGPT. So I'll share this document with you also. These documents are very important. So first one is for process tree, I think. So you see what I have written to ChatGPT. I have run the same thing and I have taken this screenshot and said that after typing ps tree minus p, I got this output. My program is output ID 582. I am saying this is my output. This is my program. Can you explain the chain? I hope you are getting. So similar kind of queries you can ask to ChatGPT also. I've just given this screenshot and said that my program is 582. And can you explain me the chain of process between 582 and system D? Then the ChatGPT is explaining me this. So this is the sequence that I've explained. First out PID, then bash. These two, as I said, bash is the terminal, and then remaining three are related with WSL. If you read it, it is here. I'll share the same thing with you also. But if it is not a exact Linux machine, then it will show something else. As I said, these three may not be there. These three may not be there if it is not a WSL system. Okay, I'll share this with you, but it is up to you. If you think that I'm just copy pasting from ChatGPT, then you are wrong. So one point you need to understand, I could have hide everything. I could have hidden everything. I just explained what I know. But that's not my intention. My intention is I should give you and I should explain you an easy approach where you should learn it. And nowadays, ChatGPT is the best way to learn. So use your time, you utilize it in a proper way. Don't just ask ChatGPT to write your assignment, but you can spend some time to learn it fast. And that's why I'm giving some reference from here. But you cannot use it if you don't know the command, right? I'm using it because I have idea about all these things. That's why I'm using it. So if don't think that I'm just using ChatGPT and based on that I'm teaching. It's not like that. But yes, if there is a support available, why don't you use it? And I think it will give you more to save your time if you spend time in ChatGPT to understand all these things. Because you, as I said, you just give the screenshot and explain that. Tell me, explain this scenario. It will explain it, and you will easily understand it. I'll share these two, and then you need to spend more time for the next assignment. See, I have also created one complete document here for system D. So if you see, the system D is the init system. System D is called init system. Init system means the fast system. From the kernel will start this system. It's called user space process. User space process means it's not a kernel process. It's the first user space process. Either it may be root or it may be other user like Sirshandu that you can see in terminal. But it is the first user space process that kernel will create. Okay. And if you go down, it is showing a very interesting thing. I hope you will understand it, right? How computers start. First BIOS, then bootloader. After bootloader, Linux kernel. After Linux kernel, then Linux kernel will start the first user space program. What is the first user space program? This one, sbin.init. And if whenever it will execute it, it will become systemd. This is the program that will start by kernel. This is the MSL. Right. This the executable file. This ELF, right? That I said. So this is the executable file which is there, which will start by the kernel as a fast user space program. After running, the process that will create is called systemd. And systemd is responsible for all other thing, the controlling the entire machine. Now, why system? Why PID one is special? PID one means system ID. PID means process ID, and process ID one is for system. So every process is related to system one, and you can relate it from here from this diagram, right? Everything is related to this. Okay. There are some point here called weight and all. You may not understand now, but you will definitely understand after 2-3 class. What is this? I am not explaining now because you will understand it after a few days. So see what after this program, it will automatically after kernel start this program systemd will automatically start some other process related to start networking, start SSH server, start display manager. So all starting these programs is the responsibility of systemd only, and that's why this is the path. I hope this part is clear now. You need to practice, or at least you need to watch my video once more. Write your own notes. It is not possible to give PPT. I'll share the document that I'm collecting, I'm preparing from ChatGPT for you, but at least you need to spend time. Whatever I'm sharing, it's not enough. Even if you watch my lecture, after that also, I expect that at least you explore some time on PS3 also. You spend some time to explore the internal details. What are the other options you can combine with PS3? Only minus P, or you can do something else also. That all these things you need to explore. Okay, let me stop this one. Now the interesting question. Interesting question is, so far I've explained that okay, I have a program called system one. System one is creating one more process. That is fine. For here, suppose 315 is a bash. Bash means this one. And from this one, it is creating one more process called simple. How exactly they are creating the process, that I have not explained. Right. I am saying that okay, system D will be there, then system D will create one more process, that process will create one more process, right? How exactly, what is the command based on that a process can create another process? That I have not explained. So now I will explain that. And for that, we need a command called fork. So I will not use it now. So now this is a simple code. So this code basically has only these three lines. Just concentrate on these three lines. Okay. Tell me what should be the output of this program. Other things are commented. Only these three lines are there. What should the output of this program? Any idea? Hello world or something else? Let me run it. GCC simple one, I think, right? No, simple fork. Fork one dot C minus O fork one. You will surprise to see hello world. Oh, no, why? I have saved it, right? Then, oh, it is simple fork. Sorry, not simple fork one. I did mistake. It is only simple fork. I gave wrong file name. Now it is. Why it is printing hello world twice? Not one. It should print follow if ignoring this thing, everything else is you familiar with all other things, right? Only this line is not clear to you. Other things are fine, right? As for other things, it should print hello world. That's it. Why it is printing two times? Because of fork. Fork is the function. If you use it, then it will create one more child process. Okay, and the concept of child fork is, suppose you are running this program, right? Suppose this program is called process ID is 100. So I need to use both just for, suppose one process is running is called 100. Okay. And it has run up to this line. So line numbers are so not showing, but suppose this is the line of fork. So here it will execute a fork. The moment after fork, then it will create, this is fine, this is its own process. It will create one more child process. Suppose it's called 101. Now, instead of one process, 100 is already there. There is one more process called 101. There are two processes. And I explained in last class, even today also at the beginning, each process has its separate address space, like virtual memory. So whenever it will create a process, separate process, it will create a separate virtual space for this. But what it will do, all the details from this process will copy there. Basically, it will be a replica of each. The parent, whenever it will execute fork, the parent will create a child. It will be exact replica of it of the same. So whatever variables are here, suppose there is a variable here called PID. It is commented here, but suppose it is not commented, then all these variables and all, it will be directly copied in this address space. Not, they will not share the same copy. There will be a separate copy. So a complete separate copy will be created for this child process. And both the process will start executing from the next line. What is the next line after fork? Printf. So that line will start executing both process. From that line, both processes will start executing from next line. So next line is called hello world. So actually what is happening here is hello world is printing by both the process. Parent program. This is just to display it. If you don't use it, you may not display everything, because whenever you are sending printf command, some of them will be buffered and it may not display on time. It may come after some time. Or so flush means you are forcefully saying that no, it should display now. So at the end, equal to right? It's not required for other, but here if I don't use it, then the hello world will not display. So that's why I'm using it. That I'm forcefully saying that whatever they are in STD out, it should display now. You can explode. I thought you know it from C course. That's why I've not explained. Huh? Why is it not actually? No, it is there. It is there. I'm not showing. I think it is there. It is there. What is it is for fork. You cannot. If you want to use fork, then you need to use this library. Huh? In the parent process and the child process, which one completes? Which one complete? Interesting question. Suppose if I ask you to print clearly. Huh. Good. Please wait for 15-20 minutes. I hope you'll get your answer. Otherwise, you can ask again. Okay. Sir, huh? Carry more information or just the information after that line? No, it will carry all the information above. So basically, if you are running a program, immediately it will create a process that I have said, right? So whenever it is creating a child, whatever the content of this process will be copied. It will copy. It will not share a common trace. Okay, it will copy. After this line, if you are trying to change a variable, that will be changed separately in each copy. It's not the same copy. So that's the difference between process and thread. I have not explained thread yet. So whenever I'll explain thread, you'll understand thread will not create a separate process. There will be only same process. but no need to understand thread now. Let us try to make it more interesting. Okay, so now I will uncomment this part. Now what it is doing is, uh, now both the process will start saying that, huh? So let me just comment this too. First, it will create two process and both are going for infinite while loop, right? It will, this parent will create one process by for, and after that both will go for infinite while loop. And what it is doing in infinite while loop? First line it is saying get PID. Get PID is a function. You need to use unistd.h, and get PID is there, this library. Get PID will get the PID of current process. If I get PID, then I will get PID of that process. And this process. PID is a variable that is of type PIDT. So you need to, PID is a type variable of type PIDT, which is used for storing the process ID. Okay. So now both the process will get their process ID, it will display it, and it will continuously do this, right? Because it's an infinite loop. So now that is the purpose why I am running it. Let's read on the process, compile and run. So see process ID, it is just displaying the process IDs. But it's, there is no sequence. It doesn't like that which one is executing fast, which one is executing second. It's not like that. There is no fixed order. You may see some order, but I think they not maintaining order only. Right? It's not maintaining order over there. Why? Can you tell me why it is not maintaining order? Can you tell me that there are two printf, right? One is printing by parent process, one is printing by child process. So why they are not printing simultaneously? Oh, sorry, in a fixed order. No switching. There are two processes, right? These two processes may be running in two different cores, and two different cores means they are executing in parallel. So simultaneous execution and parallel execution is the difference. Simultaneous means maybe they are using in same core but utilizing the space in a time sharing way, but it's not like that. There's complete separate sources, resources is there and they are running it. So now if you see, if I go for this ps minus af here, not you can see there are two program here. One you can consider it is 689, right? And so the, and another is 690. So the 690, see the parent. Who is the parent? 689. This line is important. If you see the second one, 690, its parent is called 689. 689 is also hot cost. So this is also the process that I have created. The first process is 689 that I have created through this command, through fork command. The second process that it has created here, 690, it has created by this fork function, this fork call. And that's why there are two processes, and now both the processes are running. Because of this, because as I said, after the fork, both the process will start executing from next line. And next line is this while. So that's why it is running here. Both are running from this. Now, if you go for this, sorry, not this. PS3. Now you can see the relation here also. 609 is the child process of 689. 689 is the original process that I have started. And 990 was started because of what? Right? Now you have asked an interesting question that what will happen if I kill the parent? Normally it is the responsibility of parent process to wait for the child process. Child process should terminate first, and after terminating the child process, whatever resources the child process is using, those should be freed or those should be removed by the parent process. It should be taken care by the parent process. That should happen. But since this is an user process, it may be possible that if somehow the parent is killing fast, then what will happen? I'll do this. Let me kill parent. Here, 689. It is killed. Now, if I go for the tree again, you'll see the interesting thing. Now, the child is taken care by system B. All these other things I say, they are coming for WSL, right? These are coming for WSL. If you are going for actual Ubuntu, then this is now taken care by system D. And that's why system D is very important. right? You remember these three relay and all these are coming because I'm using Ubuntu here in WSL. Otherwise, in real Ubuntu, if you go, it will go under system T. That's why it is also, if you read the document that I have shared here, in this document also it is written the purpose of system T. One of the purposes, if any process become orphan, then it is the responsibility of system D to handle it. Okay. But normally to prevent this, this is not a good scenario. It's not that you have created multiple process and now the parent is not there and now you are giving all the responsibility to system D. That is not a good programming practice. To maintain this, what you need to do, you need to maintain a command called wait in the process. That I will come this point. Now, let me stop this and I'll go to one more point here. There are many things, so I don't know how much is possible to cover. Tomorrow I'll start from 8:30 to I think we can cover the remaining part also. Now an interesting question. What this function is returning? That is a function, right? Fork is a function. Do you think it is returning something or not returning? It is returning something. So now if I write like this, PID equal to fork. Okay. And now if I want to print it, then what it will print? Let me print it here. Hello world is fine. After this, I just want to print the ID. It is actually integer. So just I write this and let me comment this part. You will see the interesting part now. One will print, if let me compile it and show it to you. Oh. So see, it is printing hello world 730 and hello world 0. Why 0? That you need to remember. This is a very important point and very interesting point also. What PID returns? So for that you need to concentrate on this line. In fact, in this line only, after fork, right? After fork, what I have said is immediately if you call fork from this process, it will create a child process, right? And from next line, they will start executing simultaneously. But I said PID is a variable, right? PID will be copied in both places, in both address space of parent as well as address space of child. In both places, PID should be there, while it will store in the stack memory location, right? If you see the virtual memory, they will store in which place? Heap or stack. This place is stack memory location. Then stack, there will be a variable called PID. It will be copied here, two different copy. Now in two different copy, in parent, it will store the process ID of child. Parent will inform that, okay, in parent, if I say that after this line, if I try to print PID here in parent, then it will display the child ID. That through this, parent will understand that I have created this child and this is the ID of. And in child process, it will give 0. Okay, so same for after fork, it will return PID, but that PID from next line, that PID will be available in both process, right? In parent process, it will give the ID of child. Here it will give the ID of nothing. It will give 0. So based on that, you can find out that which one is child and which one is parent. And that I'll do now. Maybe I'll not write a code for it. I'll show you a code. You'll understand from it. Just concentrate on this line first, and then if PID equal to 0, what do you think? Which one will execute this line? Do you think that the highlighted code will be executed by both child and parent? Which one will execute it? Okay. Only child. Why? Because PID 0 will be available only in child, and the actual process ID will be available in the parent. It will not be 0. Why? Because system D itself is 1. 0 is not there. If you see the tree, it is starting from 1. So that's why it is returning 0. 0 means this is a child process. So whatever you want that a child process should execute, you write it here. That will be executed by your child process. And whatever you want that your parent process should execute, you write in the else part. Okay? Then it will display the parent process. And now if you, can you tell me the code or what exactly it will output? What child? What child will print? Child will print the process ID of what? process ID of his own ID, because here I am using get PID. Get PID means from which process you are running, it will display the ID of same process, not the child or parent, it is the same process. So basically this program is printing the process ID of child, and the parent process will display the ID of parent process. That's it. That's why I'm not running it here. You need to, this line is very, very important line. Wait, after finishing all its task by parent, parent will wait there. It will not terminate itself. Okay, you can see, is there any infinite loop for parent? But child has an infinite loop. Let me run it and you will see this. This is simple one, right? Simple fork one. So fork one. If I write this code fork one, parent is 743, child process is 744. Right. Now, if I go to PS minus AF here, both are actually running. You see, both are running. But why both are running? If you go to the code, the parent is not should not go for infinite run. Only child is going for infinite run because the unconditional while loop is there. It's not there with parent. But why parent is also alive? Because of the wait. Wait null means parent will first finish all his task and then it will wait for the children to terminate children process. After the children process will terminate, it will get a notification that the child process that you have created that is now terminated, and then parent process should terminate. And that is the standard programming practice. And if you are not maintaining it, then that child process should be handled, taken care by the system. Okay, this switch that I have written is a very simple program, but it's not that simple. So I'll try to make it more complex next week if possible or later. But right now I'm just trying to give you a high level idea. Wait is a big program and you can use it with different, you do know about polymorphism or not, I don't know. So there are different attributes you can use. This wait null is the simple way to, very the simplest way to use this function. There are many other ways. Okay. Huh?
Trying to fill the child from other line.
Ah,
The parent from stuff.
interesting. Let me try. I have also not tried. What is the child process here? 744, right? See? Done. The moment child process terminated, parent process also terminated automatically. You don't need to do anything. Parent process was just waiting to terminate for the child process. आपने child process close किया, automatically बंद हो गए. Okay? Huh? Here? Text. Okay. Which is? PID is the type. So it is an extension of int. You can use almost same as return. There is a library here I'm using, the UniSTD. If you go UniSTD, you'll find type def. You know about type def, right? It's kind of integer and the int 64, I think.
Children has many PID into this one.
Actually, whatever code you write after that, if we execute it by both.
So in child we didn't mention PID.
Yes, that's the thing I said. What in child you didn't mention PID, but it is here, right? PID is here, and you will create a process here. What I say is, whenever you will create a process, at that time, whatever the situation of that process will be completely copied here. If you completely copy the same process here, process means the entire virtual memory, if you copy here, what will happen? PID is also getting copied here. Whatever the current value of PID, it is copying here. And after that, whenever you start running it, PID value will change. Once child will get 0 after for, and this one will get the child process ID. And after that, this point is very important. Whatever code I have written here, this is actually will execute by both. So now it is the responsibility of you to control which one should execute which letter. That's why the if PID is there. If you don't write it, then everything will be executed by everyone. If you write something here, if you write a printf statement here, then it will be executed by both. I hope it is clear to you. It will not go now because termination. Huh?
So in the process, if you see the child ID is 740 or something. Here we are mentioning PID equal to 0, so it's correct.
Oh,
Why is it zero here?
good question. So that's why I spent some time. I'll spend some more time on it if it is not clear to you. Whenever you go for a fork, you create a child process. Child process will have its own PID, right? That was 744 you are saying. Correct. It is 744. Now here it is 100, 100, 100, suppose. There is no change here. Child will have a separate process ID. But here what I am saying is what fork function will return. Whenever you will write this fork function, of this line, the PID value, right? The value it is returning in the parent process, it will return the child process ID. Okay. After for if you try to display PID, in parent process it will display the ID of the child process. Okay. And in child process it will always display 0. It is based on what the for function is returning. It is not about the ID of that process. ID of that process you need to find from get keys. Okay. Whenever you are saying for, then you are giving a command to kernel that okay, create a child. Kernel will create a child for you and then it will give a process ID also. That process ID is 101. It is a separate thing. It will give by kernel. But this fork will return PID means in parent it will return the child ID. That okay, you have created this child. This is the ID of your child, and that will be available in PID variable in parent process.
101.
No. Yeah, that should be 101. 101 is there.
Yeah, giving information we are giving equal to 0.
Huh? So, as I said, in child process, it will be 0. So, this code I want to run only in child process. Okay. So, basically, as I said, this code, if you don't control, everything will run, both process will run it, right? Whatever you write after for both will run. But what I want them, no, some part should run by child and some part should run by parent. That's why this condition is there. So, PID 0 will be returned in child process. So, if I write PID 0, then these steps inside if part will be run by child process and in else part will be run by parent process. And that's why I'm giving. Okay. Now I'll go back to this simple fork and I'll not use all this thing. Okay. This is another interesting question. What do you think? What will be the output of it? This is the only code. Remaining things are commented out. This is the only code. What do you think? What will be the output?
There is no cost.
Huh?
PID comment.
Thank you. Huh? What should the output? Huh? 4 times, 3 times, 2 times.
Four times? No.
Are you sure 4 times? Yes, it is 4 times. I'm not. If I let me run it. Yes, you are correct. It will run 4 times. Okay. Why 4 times? First time for true process. Let me go to the code and run. Maybe how to show the line number here? Do you know? I should go to next class. I'll do. Maybe I'll write here fork 1. Okay. After fork 1, you have 2 processes. Right? So fork 1, this is the parent process will continue. It will create one more child fork. Now both should start executing from the next line. What is next line? Fork 2. Again there is a fork command. So that fork command will now execute in both parent as well as child. What will happen if you create a fork here? If you execute a fork, okay, this is the main process here. It will create one more child here. And if here also if you execute it, okay, this is the parent process, one more child. So basically 1, 2, 3, 4. 4 process. It's clear? And if now if you have any doubt, then I'll just use this code. Now this code that I'm running is nothing. It is just for infinite loop. So I'm removing this part. And if I run this code now, what I have done? just for infinite loop. I don't want to kill any process. Just for infinite loop, I have added this, and then let me run it. Ah. So now, hello. Only difference is now all the four processes are running. Now go to the map. See the map. First one is 781. So this one is 781. So this 781 has created one called 782. So this side is 781. This is 781. And it has created a process called 782. Now 782 has created 784. So this side is still 782. This is still 782. This is the it has created one more called 784. And now this 781, this side is still 781, and it has created one more here. What is that? 783. So now 781, 782, 783, 784 all are run. But you can see the parent-child relation here. If you go for this PS minus AF, then also you can see the same thing. You can see the same thing. Okay. So that is an interesting question. Many times people may ask, 2 for, 3 for, how, what will be the output? If I write this printf in between here, then what will happen? I hope you will understand the thing, right? If you know the basic here, then you'll understand the remaining part.
If we have work in a loop, when both the first and second compared to this,
Huh? If
we
you,
have fourth in a loop, when I for loop.
if you, it can quickly eat up your memory also. It can be because it will clean infinite number of processes.
Finite to zero.
So you can check what you need. So thinking calling a for from a loop may be dangerous.
So
No?
parent will get like parent will create one child,
Huh?
and that parent is creating other child.
Huh?
Child is creating other child.
Huh?
Parent's child will have lower number or
You cannot say all the numbers will be given by kernel. Number may vary. That's why all the relations is required. You need to go for this chart or you need to get PID. You need, if you want to, what I have written here, get PID, right? I have used get PID many times. If you want to get parent ID, then you write get PPID. Then you will get that what is the parent ID. You don't just trust on the numbers. Number may not be sequential. You need to get the relationship. Then only you will understand. Okay. What else? Hmm. Now, one last point is maybe now so far you understood that one process can create another process, fine. One process can create another process, how using for, and maybe I said that okay, you create a process, fine, and this part should be executed by child, this part should be executed by parent, but it is still not connecting. And with one thing is how in computer, if I just click on PowerPoint, it is opening, right? You may say that, or suppose what I am doing here is, if we go here, what I have done, if I just write this command dot for in bash, bash is a process that is clear now, right? Bash is a process. In this process, I'm giving this command, it is opening a different executable. What so far I have explained it. Two process, the code is the same file only, right? Code is after fork, I have written to if PID is 0, then this is the child code. Otherwise, in else part, this is the parent code. It is not here. In bash, if you are giving this command, it is opening a new process. What is actually happening here is, after giving this command, suppose this is the command of bash, this is the original bash function, it is creating a child. But what code you are running in child? This code is not written in bash. Like what I have done here, it's different, right? This is a very simple way. Here, I have also written that what code this child should run. This is not happening here. Instead of that, what you are saying that you create a child, and that child process should run a different process. It should create a different executable. This fork here, dot fork, it is a separate ELF file, right? So you are whenever you are giving this command, it is opening a new, it is creating a child, and that child is executing a different process. For that, you need to use this one, this code, this function actually, execute function. Through this function, you can run another code here. I'll just run it and I'll show what it will do. Still, I think it will run. Yeah. So now suppose I want to run fork 1. I hope it will run. See, it is running. Fork 1 can run. So what is happening here is I am creating my own terminal. So what is happening? Suppose this is not the bash. I'm creating my own bash. This is my own bash now. So this is my program running. This is my program running, and my program is saying, tell me what program I should open for. This is what my program is waiting here and saying, tell me what program I should open for. And I'm writing a name of a program. It should be there in same folder. And this fork 1, it was previously compiled. If you go, it is there in same folder. I said open this, and it is opening it. How it is opening it? If you go to the code, you will see after the scanf here, it is going for fork. After fork, it is creating a child process. And inside the child process, I am calling this function. And this function is, through this function, you can run any other process or any other executable here. This child process will be replaced by that file. So since I have entered through scanf fork 1, so this child process will be replaced by fork 1. So in place of child process here fork 1 will start executing. And family process is still here. Exactly the same thing happening for bash. If you go for bash, what it is doing, suppose I am running directly fork 1 from here. Bash is a program. And it is going, if you give this command, it is creating a child, and that child is now called fork 1. Bash is still going its own way. It can run another program also, it can wait for this. It is its own responsibility, right? So this is how the complete structure is. Once you start the power button, your machine is on, right? BIOS, bootloader, kernel, then systemd, your machine is on. Now, if you click anything, or if you give command, type a command here, or you are clicking in anything, actually it's the same thing. One process is creating a child process. That's how your complete program is running. Either you are giving a command, or suppose I'm using a mouse and I'm clicking the one photo or something to click it. Actually, by this, you are doing the same command. That okay, you are giving a command to a processor, open a new process. So that process will go for a fork, create a child, and in child process, it will run the program process. The parent process will also there, child process will also run. And that's how a complete program, computer is running. Everything is based on this concept. I hope all these dots are connected, right? So I'm recording it. This is very important to understand that how your computer is working. It's my intention is not here to teach you OS. OS you will learn in your OS subject. I am teaching here how computer works. Because many times this question may comes to your mind, right? That I am clicking something, how it is opening, or I am giving a command, how it is program is opening. This is what internally happening. Kernel, then kernel is opening systemd. From systemd, every time if what are the functions, it is one by one, it will create the child process. And one child process is called bash. How bash is opening? I am starting bash from here, right? I'm going here, and moment I'm clicking it here, one bash program is starting. One bash started. This is the bash program. From bash, I give one more command, it will create one more child. And everything will be related through this relationships tree, right? It's clear? So I'm stopping the recording here. Please, I'll share the recording like